Welcome back to math. This is section 20 on functions and nonlinear equations, doing the practice problems. Problem 1 says, for what value of x is f of x, and I'll read it in a moment, undefined. F of x is x plus 3 divided by x minus 2. Well, it would be undefined where the denominator equals 0, so the denominator, x minus 2, if that were 0, that would be where x equals 2. So for x equals 2, this function would be undefined. Problem 2 says, is f of x equals x squared a valid function? Well, we just saw in the instructional part of this video the graph of y equals x squared, and f of x equals x squared is going to look quite a bit the same. It's going to be a parabola, vertex at 0, and the arms go up like this. And we can do the vertical line test, and we can place any vertical line all the way through this, and we would only cross the graph once. So yes, it's a valid function. Problem number 3. What is f of x for x equals 7, and here's the function, f of x equals 2x minus 5. So that just means we need to take our domain member, or 7, and put it into f of x. So f of 7 is for 2 times 7 minus 5. 2 times 7 is, of course, 14, minus 5 is 9. So f of x, where x is 7, the answer is 9. Problem number 4 does some operations with absolute values. Remember, absolute value is always positive because it's a distance. So the absolute value of negative 10 is 10. The absolute value of negative 5 is 5. So 10 minus 5 is, of course, 5. Problem number 5 also uses an absolute value. And so we're looking for the absolute value of negative 5. It's the same as the absolute value of 5. It is positive 5. And that implies that there's some multiplication because it's next to it. So 3 times 5 is 15. Practice problem 6a says, what are the coordinates of the roots y equals x squared minus 2x minus 24? So that's y equals x squared minus 2x minus 24. So we should be able to factor this using FOIL and looking at the factors of 24. Remember, one has to be positive, one has to be negative, and we'll find that x plus 4 and x minus 6 will work out to get us back to this. So that means that to find the roots, that's where y equals 0, and y equals 0 where either one of these is 0, or x minus 6 equals 0. So we'll solve for x. X is negative 4, or x is positive 6. Those are the values for x that when we put them into the original equation will make y equal to 0. And where y equals 0, that's the x-axis. So these are our x values, negative 4, and of course the y value is 0. That's what we're trying to get, and 6, 0. So those are the coordinates of the roots. So 6b takes that problem and goes a little further and says, all right, if those are the roots, what are the coordinates of the vertex of the same equation? So there's two ways to find the x value of the vertex. The first way is to average these two. Remember, a parabola is symmetrical. That means that the axis must be down the center. The vertex must be between the two of them. So we can take the x values, negative 4 plus 6, divided by 2, that's the average of those. Negative 4 plus 6 would be 2. 2 divided by 2 equals 1. The other way to find that, there's a little formula that says x equals negative b over 2a. And that means you have to go back to this equation, right? This is b here, right? This is a would be 1, B would be negative 2, and C is negative 24. Again, taking those coordinates, taking those coefficients from the original equation. So if B is negative 2, then the opposite of B, negative B, is positive 2, and 2 times A, also 2, and that's 1. So that's two ways to find the x value. To find the y value, we're going to take the value that we just found for x and substitute it into this equation for x. Every time we see an x, we've written a 1. So y equals 1 squared, that's 1, minus 2, minus 24. So 1 minus 2 would be negative 1, and then minus another 24 would be negative 25. So the vertex coordinates are going to be 1 for x and negative 25 for y. And finally, problem 7. Use the quadratic formula that's written here to find the roots of the parabola y equals x squared plus 2x minus 8. So let's remember that this is in the standard format. So a, there's no coefficient next to the x, so a is understood to be 1. B is a positive 2, and c is negative 8. So let's substitute that into the quadratic formula. So x equals negative b, that's negative 2, plus or minus, because we're going to have both a positive and a negative answer for the square root. B squared, that's 2 times 2 is 4, minus 4 times a, that's 1, times negative 8. I'll extend that out, and that is all over 2 times a. Well, that's 1. Okay, so negative 2 plus or minus. I think once you get this far, it's just a matter of being very careful not to make a mistake in copying things down. So 4 minus, but this is a negative 4 times a negative 8, so that's going to be a positive 32. Again, that's over 2. So negative 2 plus or minus, that's going to be the square root of 36, right? 4 plus 32 is 36. The square root of 36 is 6. So we have negative 2 plus 6, that would be 4 over 2. That's one of the answers. 4 over 2 is, of course, 2. The other one is negative 2 minus 6. That would be negative 8 over 2. That would be negative 4. So our roots are going to be 2 and negative 4. The coordinates then would be 2, 0, and negative 4, 0.